Hello all, I am Muhammad Kamran Halil from YouTube channel The Twins Academy. Today we will discuss A-level physics. Topic is kinematics. So today is the part A of the kinematics will be discussed, in which we will discuss the distance. We will discuss displacement, then speed, velocity and acceleration in detail. Now first of all, the distance. Consider an example that if this is city A and this is city B. Now we will move from city A towards city B. This path consists of straight lines as well as curved region as well. So now this is the actual path traveled by an object. So actual path traveled by an object. So this is called distance. The distance can be in a straight line. The distance can be in the straight line. Distance can be in the curve form. Distance can be combination of straight lines, then zigzag path, whatever you want to say. So there is no particular direction. So distance is a scalar quantity. So you have to remember that it is a scalar quantity. The distance is measured in SI unit, which is meter, small m. The other unit may be use kilometer or the centimeter, but the SI unit is meter. Now we will move towards the displacement. If I want to move from A towards B, okay, in this example you can see that if we will travel in a straight line, and this straight line will give you the shortest path between two cities A and B. So actually that path is the displacement. So how can we define the displacement now? The shortest, so this definition of the displacement is the shortest distance between 2 points, and that points are the initial and the final position. The shortest distance between 2 points in a particular direction. So that is called as the displacement. Okay, it is a vector quantity because it consists of a particular direction. So specific direction is involved in case of the displacement. Now the question is, can distance and displacement same or they can be different? So there are different examples. If we will talk about that, we will travel, let's suppose. Now this is the 20-meter distance from A to B. There is no other path from A to B. So my distance will be 20 meter and my displacement will also 20 meter because there is no other or alternate route to reach from A to B. So yes, distance and displacement can be same. So this is the example when both are same. If I will move from A to B 20 meter and then B to C backward direction for 5 meter. So now what is the total distance? Total distance travel will be 20 plus 5, that is equal to 25 meter. and the displacement. Now initial position is A and final position is C. So what is this gap left? 20 minus 5. So that is equal to 15 meters. So when you will start moving backward to the original direction, original destination, your displacement will start decreasing. So is it possible that the distance will travel but displacement will be zero? That is the question asked in the past paper as well. So when we will move towards the past paper, we will see that what will happen in that case. So if we will move from A to B 20 meter, this is A, this is B, and then we will move backward from B to A 20 meter. So now this is my initial, this is my final. So distance traveled will be 40 meter, but displacement will be zero because initial and final are the same point. Or if you can say that if you will move one complete path in a circle, then what will happen? The distance will be traveled, which is 2 pi r, the circumference of the circle, but the displacement will be zero. So now the other definition related with this video, related with this topic, is the speed and the velocity. So how can we define speed? Then we will move towards the velocity. So speed is distance traveled per unit time. Distance traveled per unit time. So speed is represented by v, distance is represented by s, time is represented by t. The unit for the speed is meter per second and the other unit is kilometer per hour, but the standard SI unit is meter per second. So speed is a scalar quantity because that doesn't involve a particular direction. So then we will discuss the velocity. So velocity is displacement traveled per unit time. Displacement traveled per unit time. So velocity involves the displacement. Displacement is a vector quantity, so it means that velocity will show short. It is a vector quantity because the displacement is involved. So speed is a scalar quantity and velocity is a vector quantity. Now how the velocity of an object changes. So we will discuss examples related with this, that under which circumstances the velocity of an object can change. For example, a car is moving in a straight line. There is no change in direction, but its speed is increasing. So 10 meter per second, then 20 meter per second, or 30 meter per second, or 40 meter per, or it can be vice versa. That 40, then 30, then 20, then 10, then 5, 3, 2. So there is no change in direction, but gradually the magnitude, the value of the speed is decreasing. So it means that there is change in velocity. There is change in velocity. So why there is change in velocity in this particular case? Because the magnitude of the speed is not changing. Another example, because these examples will helpful in order to solve the past paper question. An object is traveling in a circular path with the speed of let's suppose that is equal to 10 meter per second. So is there any change in velocity? If you say no, you are wrong. If you will say yes, you are right. There is change in velocity. There is change in velocity. Object is moving with constant speed. I have said that with the constant speed, not the constant velocity. For the constant velocity, the object must travel in a straight line and with the same magnitude. But now in this case, there is change in direction. In circle, at every point, there is change in direction. So change in direction means there is change in displacement, and change in displacement is change in velocity. Change in displacement. So there is change in velocity. So if this question will be asked in a paper that if an object is moving in a curved path or in a zigzag path with the constant speed, with the constant magnitude of the speed, is there any change in velocity? Yes, there is change in velocity. And what is the reason? You will write down that due to the change in direction, there is change in displacement. Now next we will move the conversion that for example the conversion is very much important. He will say convert 100 kilometer per hour into meter per second. So 100 multiplied by 1000 divided by 3600. Or simply what you can do, whatever the value is given, divided it by 3.6, you will get same answer. And if you want to convert meter per second into kilometer per hour, then let's suppose that the value is given 100 meter per second, that is required to convert into kilometer per hour. So what you will do, 100 multiplied by 3600 divided by 1000, or simply what you will do, 100 multiplied by 3.6, you will get your destination, you will get your answer. So this conversion is very much required in the paper solving technique. So simply if you want to convert from kilometer per hour to meter per second, divided whatever that value is given by 3.6, and if you want to convert meter per second into kilometer per hour, then whatever the value is given, multiply it by 3.6. That is the easiest way for the conversion. Many students are very weak in order to do conversion due to the lack of practice. So this is a very tricky way in which you can convert the kilometer per hour into meter per second and meter per second into kilometer per hour. Now the acceleration. So acceleration is, so how can we define the acceleration? It is the rate of change of displacement. Rate of change of velocity, not the displacement. So whenever there is change in velocity, we will say that there is change in acceleration. The symbol for the acceleration is small a, that is equal to v minus u by t. The unit for acceleration is meter per second square. So v is the final velocity, u is the initial velocity, and t is the time. So u is initial velocity, v is the final velocity. Okay, now we will move towards the questions which I have copied from the past paper. So what is the displacement? The shortest distance between 2 points in a particular direction, that is called as the displacement. Use your definition to explain how it is possible for a car to travel a certain distance and yet have zero displacement. So you can give any one of the two examples which I have given, that if the car is moving in one complete path in a circle, then it will cover the distance, but there will be no displacement. Or the other example you can quote, that if car will travel in a straight line from A to B and then return back to its journey, return back to its destination, then the distance will be traveled but displacement will be zero. So that is the explanation of this question. Again, the definition of the displacement is asked. So this is the repeated question, so just leave it. Distinguish between the scalar quantities and vector quantities. So for the scalar quantities there is a magnitude, and for vector quantities there is a magnitude. along a particular direction, because velocity is a vector quantity and vector quantities must have a particular direction. He's saying mark the scalar quantities, so energy doesn't have any direction, mass doesn't have any direction, power doesn't have any direction. While on the other side, acceleration, force, and weight are marked as the vector quantities. Next question, a student walks from A to B along the path shown in the diagram 2.1. The student takes the time t. So the time is given for moving the student from A to B. State the quantity apart from t that must be measured in order to determine the average speed of the object and the average velocity of the object. Now speed contains the total distance over total time. So time is given. So what quantity is required for this answer is total distance, because according to the definition of the speed is the rate of change of distance or distance traveled per unit time. For the second question, in order to calculate the velocity, we must have a displacement, and displacement will be in a straight line. So what is required in order to calculate the velocity? We must have total displacement from A to B. So this is the quantity which from A and B. This is the quantity which is required to measure the velocity, because the definition of velocity is rate of change of displacement. So then the next one, again the past paper question, a stone on a string is made to travel along a horizontal circular path. The stone is constant speed. He is saying speed. He is not saying that it is moving with the constant velocity. So define acceleration. Acceleration is rate of change of velocity or change in velocity per unit time. So definition we have already done. Use your definition to explain whether the stone is accelerating. Yes, definitely stone is accelerating. Why? So first of all, you will write down yes. And what is the reason? Change in direction. Because whenever the object will move in a circular path, in a zigzag path, there is change in direction which will change its velocity. So change in velocity, it means there is acceleration. So change in velocity will definitely produce acceleration. Although the magnitude is not changing related with the movement of the stone, but there is change in direction at every point in the circular motion. So the direction changes mean velocity changes mean there is 100% sure shot there will be acceleration. So if you have any question, kindly ask in the comments, like this video, share this video with your friends and colleagues, and stay tuned for more videos related with the kinematics topic of AS physics. Take care. Bye bye.